I'm Larry Head. I'm a professor of systems and industrial engineering at the University of Arizona. I'm the moderator for today's session. Thank you for joining us. I'd like to introduce our three panelists. Today we have Boris Shulkin. He's the Executive Vice President of Magna International. In his role, he reports to Magna CEO Swami Kotagiri, an assistant helping the overall technology strategy development and in the rapidly evolving mobility landscape. Our second panelist is Ziv Benjamini. He's the CEO of Fortelix. Ziv is a verification visionary and a passionate leader. Prior to founding Fortelix, Ziv served as the corporate vice president at Cadence, running the simulation and verification business. And our last panelist is Omer Kilov. He spent 21 years driving cutting-edge technologies from inception and commercialization. As the founder and CEO of Innoviz Technologies, a leading provider of LiDAR solutions, Mr. Kilov is helping enable the mass commercialization of autonomous vehicles by providing high-performance LiDAR at mass market prices. So what I'd like to do is start off and give each of you an opportunity to tell us a little something about your company, your background, and sort of your vision of the present state of level 3. Okay, so let's start with Ziv.
Okay, hi. So I'm Ziv Benjamini. My company and myself come from a different background we come from the chip industry, where we have transformed the way semiconductor chips are being verified today. If you go today to any company that's doing complex chips, they are using the methods that we've introduced into the industry a couple of decades ago. Fortelix charter is to enable the verification of automated driving systems, starting from ADAS, but many other automated systems and autonomous vehicles in many distinct verticals. The problem with the automated driving systems is that while the industry already invested tens of billions of dollars in the development, it is still very far from maturity, and we'll talk about ADAS in a second. And the problem is, and the reason is that this is the most complex system that humans have tried to develop so far. And these systems need to operate in an extremely complex environment. In order to properly test these systems, one have to test hundreds of thousands and millions of distinct scenarios. And for that, you need automation, and this is where we come. Our company provides a platform for automating the whole process of verification and bringing to safety, providing metrics for where you are. I just want to say on ADAS that this is really the beginning of automation. This is the part that's already starting to become in deployment. But there are a lot of issues with ADAS. Even today, a recent publication by AAA reported that, and they've tested several of the most advanced models, ADAS models, level 2, we're not talking even level 3. And they found that there is an issue every 8 miles, some kind of an issue. ADAS systems are very far from readiness, and they need a lot of help to get there. So it's great that we are moving to level 3. We'll talk about that. But there's a lot of issues still that needs better verification and better robust solutions to get ADAS to the safety required.
Thank you. Omer, let's go to you next. Tell us about
Innoviz. Yeah, sure. I'm happy to tell you. So Innoviz is a company that was founded in 2016 to develop a technology which is called the LiDAR, in order to bring LiDARs to high performance and low cost. One of the first people in the industry, maybe the first person in the automotive industry that identified Innoviz as a potential technology was actually Boris, who is on the line with us. Boris was in touch with us from almost the first day of the company. Later, it led to a partnership with Magna as a tier 1, which we work with in order to bring innovation to the market. So our first product is Innovis One, and that's also a product that we work with Magna now to push to the industry and bringing level 3 automation to a BMW series production. We recently went public through a SPAC, and we are working on our next generation LiDAR Innovis 2 and continuing to push the boundaries to bring safe autonomous driving to the market.
That's exciting. So Boris, tell us about Magna and your role there.
Oh, thank you. Great meeting you all. And Omer, thank you for the kind words. So about Magna, couple words on Magna first. So for those that not familiar, Magna is one of the world's largest auto suppliers in the mobility space. It's a company with over 60 years being part of the industry. It's a $40 billion company, just north of $40 billion revenue company. We're the largest tier 1 supplier in North America, the 3rd largest in the world. But the important thing about Magna, maybe just a couple of the words on DNA of the company. We like to think of ourselves as that we kind of innovate like a startup, but operate like a mature enterprise. We look for ways to leverage our scale in terms of integration of different products. Couple of the maybe unique things about Magna in the tier 1 world. We're not only very, very diversified. It's probably easier to describe what we don't do. We don't do tires. We don't do the engine itself. Pretty much everything on the vehicle that you find Magna does somewhere in the world. But even more importantly, we're the only tier 1 with a full capability to engineer and manufacture the entire vehicle. And we do this for many of our existing OEM customers. So that system level thinking, an ability to think like an automaker without having its own brand, I think that's what uniquely identifies Magna as a company in the mobility space. So now switching back to the ADAS topic, we've been in this field for a very long time. We started this in the 90s when nobody thought that camera belongs in a vehicle. We were the first company to bring Mobileye as one example to the volume production in North America, 2007. One of the largest vision-based ADAS supplier in the world today. But overall, if I were to kind of describe our thinking of ADAS, today our ADAS portfolio covers complete range of features and functionalities, all the way to what's defined today as L2+. We focus on mass market NCAP requirements and ability to deliver entire system. But we also, continue developing next generation technologies. Omer already mentioned, for example, things in LiDAR space. We have a unique offering in the market in digital radar space as well, and many others. So maybe an overall view is on the market, we see a very, very significant take rates increase in the level 1, 2 plus in coming years, and a lot of interest continues in the high level of autonomy because for number of reasons. First of all, technology always enters the low volume first in order to become the high volume later. So you always have to stay on top of it and be able to deliver it. But also some of the high level technology is slowly starting to enter the production even today, and that's why you have to be involved in this early on in order to stay when the volume comes in.
Great, thank you. As you and Boris talked a little bit about ADAS, I want to ask, can you tell us what is level 3? So we're talking about the present of level 3. So let's try to be clear if you can. What is level 3 and what's not level 3? Maybe that would be a way of doing this.
Start with saying that level 3 is actually the first level where the driver in front of the wheel is not required to overlook the car driving. There is a quantum leap between level 2 and level 3 in the sense that this is really the first time that the car maker is responsible for when the car is driving. Obviously, you need to go through a lot of validation. You need to have sufficient processing power and the right sensors in order to mitigate all of the use cases that are needed in order to allow the driver to completely disengage until called back in cases.
So maybe I'll add a few words here. There was a recent clarification from SAE on the different levels. SAE first was the one that published the 5 levels. So a few days ago, they made some clarification because there's a lot of confusion in this area. So they've changed the terminology. They've called level 1 and level 2 automated driving system. They call them driver support systems, as opposed to automated driving systems that's used for level 3, 4, and 5. That means that in the 2 levels, the human driver is a primary actor, as Omer correctly just said. So in level 3 and 4 have significant difference in the fallback scenario. So from a technology point of view, they're very similar. They have to operate in a sense and have an ability to operate independently. The difference is that level 3, the car will perform some automated functions, but will eventually hand control over back to the driver. And for level 4, on the other hand, the vehicle will warn the user, but will nonetheless maintain the control. And so what that really means is that the difference between level 3 and 4 is not so much in the capability, but in a level of fallback, which means that, you know, in some cases it's a cost, in some cases you need to add other ways of getting the car to the fallback scenarios. And then 2 more things that were added in the new definition is they introduced the new notions of remote assistance and remote driving, which a lot of people were using, but it was never formalized. Now it is.
Yeah, great.
Maybe, Larry, maybe a context on kind of in terms of the market adoption and deployment. So what we see today, you know, in this level 1, 2, 3, 4, today, level 1, 2, and 2 plus are what's out there in the market. And level 3 is the first, the next step that will start to be deployed. Actually, the UNECE, the United Nations, regulation body, issued the ALKS, which is the Automated Lane Keep System, as the first regulated level 3 function. And the UK just announced that they will start to adopt it in the coming year. So ALKS will be the first level 3 function that's actually starting to be, we'll start to see that on the roads in the UK and some other countries.
So, yeah, that's great. So, Boris, tell us, what is the state of production and manufacturing? Where is level 3 in that? If we're seeing some things being adopted, are we beginning to see them appearing in cars that will be on the market soon?
Well, as I mentioned earlier, the really automotive industry, when you're talking about the high volume, the programs is focused on the level 1, level 2, level 2 plus. And that's where significant take rates increase, and CAGR year over year is expected to continue to grow. We're already in low double digits, but it's expected that it's going to grow into high double digits. There's 2 aspects to this, the way we think. One aspect comes from the regulations, from NCAP and similar type of scenarios. The other one is from the consumer acceptance. As more consumers start seeing these functionalities in their vehicles, they start liking them and wanting more of it. So in terms of the level 1 and level 2, we expect a significant growth in coming years. At the same time, the technology that's important for high level of automation continues to develop, even though the industry overall in the last year or 2 kind of realized that the timelines that were expected for a high level of automation are maybe shifting a little bit to something more reasonable in the future. That these levels of automation we expect will start from like a fleet type of scenarios where there is a smaller fleet as opposed to, let's say, privately owned vehicles. And we believe that those features will enter first through fleet scenarios before they become commonly available in the future to the wider market.
That makes sense. Seems like one of the real enabling technologies are these advances in sensors. And so, Omer, you're in the LiDAR business. Tell us about, how this is an enabling technology for level 3 and above.
Sure. So as we said earlier, the gap between level 2 plus and level 3 is the ability of the car maker to safely drive without the driver supervision. It means that it needs to have redundancy. Today on level 2 plus, they use cameras which tend to deteriorate over low light condition, stray light, or even a drop of water can blur the camera. In order to overcome that, you need to add another sensor that is not sensitive to those cases. The only sensor today that is recognized as such that can provide full redundancy and complementary to the camera and radars that are at very low resolution compared to cameras and LiDARs is a LiDAR. So obviously, having a LiDAR which is significantly smaller, cheaper, and high reliability is a solution to this problem. We are also introducing our next generation Innoviz 2, which is going to be even significantly cheaper and higher in performance in order to have LiDARs also penetrate into the level 2 plus, which I agree with Boris would become greater over time. And I see that as a first step forward for the industry to move into level 3 later.
Yeah, it seems really important. And Ziv, you mentioned earlier about the complexity of the system. And I think about moving from 2 to 2 plus to 3 to 4. Talk to us about safety, because consumers are very concerned about safety. And in the US, we lost over 36,000 people to traffic crashes last year. And the promise of the technology is to reduce that. So, you're in the verification business. Talk to us about testing and safety. And
when you go, start from what you said, when you move from one level 1 to level 2 to 2.5 to 3, the complexity grows, and the number of, the simplest way to think about complexity in this is the number of tests you have to run, the number of different situations you have to actually test. And the numbers grow by orders of magnitude. It's not it's not a linear growth, it's an exponential growth in the number of things that you have to think about and not even think about. One of the problems when you get to this huge space is that we cannot rely anymore on humans to think about all of the situations and the combinations of different things that can go wrong, and you need something else. The other thing that we mentioned earlier is, and that's a big jump until level 2, 2 plus, and however we expand it, in the end, the ownership is on the human driver. He's responsible all the time, hands on the wheel, eyes on the road, and he's responsible. So if we make mistakes, the automated system make mistakes, it's fine. Even if it's 80% or 90% or 99%, it's good enough. Once you jump to level 3, it cannot be, and the system have to be reliable and safe to be able to hold and do all of the right things. And even when it wants to transfer control to the driver, there's still several seconds until the human driver will take over. So you have to know what to do in some different situations, stop on the side of the road, slow down, and etc. The number of these human-machine interaction situation is also exploding when you get to level 3. And all of this need to be robustly verified. And not just, you have to do it and you have to be able to demonstrate it. So you have to somehow be able not only to create this almost infinite number of different tests and scenarios, you also need to be able to demonstrate and provide metrics that show yourself and the regulator that you've tested everything that you think should be tested. So the good news is that there's a lot of progress in the industry. For example, there is a standard that is evolving that define how do we even define scenarios? How do we communicate between, within a company and between the different companies, between providers and integrators like tier one and OEMs, and between them and the regulator, insurance companies and municipalities, using a common standard scenario description. The standard that is now in definition is called Open Scenario 2.0. We are very actively participating in the definition of this standard. In fact, it is based on the concept of the language that we've came up with at Fortelix.
Seems like this ability to transition from automation to the human driver taking over is really key. And so, Boris, what's going on in the industry? Do you see anything, working on the scenarios and such? But is there something going on in the design of the vehicle that is going to, or the training of drivers? What are we going to do to be able to do this?
Well, actually, there's a lot going on in the industry. It's a very, very important topic. What Ziv's been talking about, the testing and validation of these new features, is an extremely important part of it. There's two sides to this, as always, right? One of them is the industry needs to do and needs to demonstrate to internally and also externally that they're doing everything they know to do in order to test and validate these different scenarios. And the amount of testing validation is incredibly high, both physical and virtual. It's extremely nonlinear. Sometimes it feels to the newcomers to the industry that, ability to go from a 0 to a 90% seems kind of linear and easy. It's the last 10% or the last 1 or 2% is the most difficult one. The getting all the edge cases and covering them. Just to give you a feel what it means to test and validate at a system level on a vehicle, and I know Omer and Ziv both know it very, very well, is things like even changing location of a sensor or slightly modifying the field of view of a sensor. That seems like what's the big difference here? Basically causes for complete revalidation at the system level. So that's important, very important part, very costly, very time-consuming part. Why is this so important to test and validate this externally? Is because it's the confidence level to the end consumer. End consumer needs to be not only feel comfortable when they use these features in their real life, but also they need to be comfortable when time comes in those, fraction of a percent of cases when it's important, they know that everything has been done to validate the correct behavior of the system. That's what industry is very busy with, and just preparing for next generation of technologies, the next generation of the volume up tech for that tech.
I'm really curious about the human factor in this, because I can see a new driver that doesn't have a lot of experience in recognizing conditions in the road, and a very experienced driver, and then maybe an elderly driver who, quite a range of capabilities that are of drivers. So, go ahead.
Sorry, I was just, that's a very, very important and interesting topic, what future holds for this. Like you mentioned, there's always some benefits and some disadvantages. The benefits are obviously that these features will allow, let's say, older drivers to, continue being efficient in the society and be able to move around in a more safe way, or even in some cases simply move around where they couldn't do that before. But at the same time, what does that mean for not just young drivers that never had a chance to experience, operating the vehicle without all those extra features, but also what does it mean for regular drivers that gotten used to systems behaving in a certain way and having these features in place, and when they fail to operate properly, are they ready to take over and do what needs to be done? We've seen this in other industries. This is it's we're bordering here on psychology and the technology. In my mind, that's just me speaking, that process is inevitable, and we as an industry and society are going to have to figure out how to make that transition.
Yeah.
Harry, if I can add something.
Please.
So I think that we should also look at what Tesla was trying to do. There is one way, which is trying to validate everything on your own or simulate, which obviously add a lot of value. What they try to do is to make something as cheap enough in order for them to sell it to sufficient number of people where they can actually experiment in real life conditions. That's I would say, a very ambitious goal, and trying to make the most of the lowest cost platform. It turned out, and I think it's clear now, that it is not sufficient. I mean, the platform they use is not allowing them to go through the glass ceiling of level 2 to level 3. I think that a very important next step should be incorporating more sensors, such as a LiDAR, which is cheap enough in order to have sufficient number of cars on the road with all of the platform that you want to have, even on a level 2 plus platform, which allows you to have a safety driver, the passenger, in order to provide supervision to when the car is actually driving and validating. You want to have the ability to crowdsource validation through cars that have the sufficient processing power and sensor outdoor. That will give you definitely the strongest probability to converge with the least risk.
Yeah, great. So let's wrap it up by asking the following questions. I'll throw it out and each of you could comment, but what's it going to take to make the industry move a little faster to go from level 2 to level 3?
So again, just to continue what I just said, I think once you add sufficient sensor and processing power, and you validate the problem, right, the application through crowdsourcing, you don't really need to take the risk in launching such a car. You can actually bring it to market much faster, and you can get to much higher confidence over time by using not 10 cars that are testing your application, but actually thousands of cars a day, to the point that you see that the platform is mature enough and you can actually calculate the risk that you're still holding. I think that will actually push the industry. This is why we are pushing Innoviz 2 to the market, which should allow it because of the much lower cost that it's offering.
I think as we move to the higher levels of automation and level 3 specifically, in the present, there must be better platform for standards and regulation that are agreed upon and are actually measurable, so that we can actually trust that those systems have been tested sufficiently. I want to say that testing, one of the things that's happening, you cannot test anymore. Obviously, physical testing, like getting a fleet of cars on the road and testing is a must and will continue to be. But in the massive space that we're talking about of scenarios, you can't do it anymore in physical testing only. You must use a virtual world with simulation. So simulation is a critical technology. Of course, simulation must be accurate. But some of the situations, you want to know that the car will be safe enough to deal with these near accident situations. And luckily, these happen pretty rare in the physical world, and we should keep it that way. But we have to test it. You can only test it in a virtual world where you can actually almost have accidents. That's fine. Nobody get hurt. So we need those. We need the standards. We need them to be measurable. There needs to be a way where you can prove. We have to go far beyond NCAP, which is the most basic. NCAP is really covering very little. I know they are working on the next level and also including virtualization. But there needs to be a standard that people can actually trust that is sufficient to ensure the safety of those level 3 cars.
You want to have the last?
I was going to say I don't have much to add. I think Ziv and Omar covered that really well. I agree completely with both. That it needs new technologies to continue to develop. Needs attention both from technical technology and the finance community, and it does need a lot of agreement of some sort. Doesn't have to be government-driven regulations, but it needs to be some sort of standardization about how, what do we. How do we measure? What do we measure against? And some kind of a common language. The only thing I would add to both of these is I believe the industry as a whole is driving in that direction very strongly right now. We may not see it because you can't go to a dealer and buy this today at the dealer. And I don't expect that these levels of automation can be at the dealer available anytime that soon. However, the industry is very, working very aggressively as an industry and in partnerships across the industry and the government on all these topics. So I do believe there's a lot of attention there from all three sides of the community: regulators, the people that finance all this, and technologists, and the industry as a whole. So I believe that's a super important topic. I think we're in a, relatively speaking, early days of that development. And it's exciting to see what's going to happen next.
It is exciting. And I'd like to thank all three of you for your insights in this area. It seems like there's an enormous amount of opportunity and challenge in this really complex socio-technical problem that you're working on. So thank you. Thank you for your time, and thank you for being part of the conference and the session today. And with that, I'll wrap it up.